When we imagine the most precious, impossibly rare materials in the universe, our minds go straight to science fiction. We think of antimatter, rare earth elements mined from passing asteroids, or diamonds raining from the skies of Jupiter. But what if I told you that the rarest, most chemically complex commodity in the known universe isn't some glowing space crystal? What if it's the thick, black sludge we pump out of the ground to fuel our cars? Gold. The universe is full of it. Neutron star collisions forge tons of it regularly. Diamonds? There are literally planets out there made of them. But oil? Crude oil, petroleum, might just be a cosmic anomaly. In a universe spanning 93 billion light-years, Earth might be the only place where it exists. Today, we are looking at the mind-bending astronomy and biology that proves why gasoline is more exotic than star stuff. To understand why oil is so rare, we first have to look at why the things we think are rare on Earth are actually incredibly common in space. Take diamonds, for example. In 2012, astronomers identified a super-Earth exoplanet called 55 Cancri e, located about 40 light-years away. Because this planet is incredibly carbon-rich and subjected to immense internal pressure and temperatures exceeding 3,000 degrees, scientists estimate that at least a third of its entire mass is pure diamond. It is a literal cosmic diamond mine, twice the size of Earth. And it's not an isolated case. Deep inside the atmospheres of gas giants like Jupiter and Saturn, lightning storms turn methane gas into soot, which hardens into chunks of diamond as it falls, meaning it literally rains diamonds in our own solar system. The same goes for heavy metals. When massive stars collapse or neutron stars smash into each other, the raw physics of the universe forces atoms together, forging heavy elements like gold, platinum, and uranium. A single neutron star merger can produce an amount of gold equivalent to several times the mass of our moon. Space is practically throwing precious metals into the void. But if you pointed a telescope at 1 trillion different star systems, you wouldn't find a single drop of oil. Why? Because to make gold or diamonds, you just need basic physics, raw elements, and crushing force. To make oil, you need something far more fragile, stubborn, and chaotic. You need life. Now, some planetary scientists might jump in here and say, wait a minute, what about Titan? Saturn's largest moon, Titan, is famous for having literal lakes and rivers of liquid hydrocarbons. In fact, NASA's Cassini spacecraft revealed that Titan has hundreds of times more liquid hydrocarbons than all the known oil and gas reserves on Earth combined. So doesn't that mean oil isn't rare in space? Not exactly. There is a massive difference between simple hydrocarbons and crude oil. What's sitting on Titan is abiotic methane and ethane, very simple, short-chain molecules created by solar radiation interacting with atmospheric gases. It's basically liquid natural gas. Crude oil or petroleum is a completely different beast. It is a highly complex, chaotic cocktail of hundreds of different long-chain hydrocarbons, cyclic alkanes, and organic polymers. To build those heavy, complex molecular chains, you can't just rely on basic space chemistry. You need biological lipids, fats, and proteins. Titan has gas, but it doesn't have oil. For that, you need a living world. Now, before we talk about trees, we need to address the giant, scaly elephant in the room. Growing up, you were probably told that fossil fuels come from dead dinosaurs. You were led to believe that when you fill up your tank, you're burning liquefied T-Rex. I hate to break it to you, but that is a lie. Oil doesn't come from dinosaurs. In fact, most of the oil we use today was already cooking deep underground before the first dinosaur even walked the Earth. The true story of oil is much weirder, and it involves a time when Earth forgot how to rot. Welcome to the Carboniferous period, roughly 300 to 360 million years ago. Earth was a hyper-oxygenated greenhouse, dominated by massive, swampy forests. But these weren't modern trees like oaks or pines. They were primitive, towering plant giants. And they developed a brand new biological superpower, a complex organic polymer called lignin. Lignin, the rigid molecule that makes wood tough and fibrous. It allowed ancient plants to stand upright, grow hundreds of feet tall, and dominate the landscape. Lignin was an evolutionary masterpiece, but it created a massive planetary glitch. Because it was entirely new to the biosphere, the fungi, bacteria, and microbes of the era had not yet evolved the enzymes needed to digest it. Today, when a tree dies, mushrooms and bacteria break it down in a few years, but during the Carboniferous period, when a tree died, it just sat there. For millions of years, millions of tons of wood piled up in suffocating, oxygen-starved swamps. Because these trees refused to rot, a bizarre side effect occurred. Normally, decay consumes oxygen and releases carbon dioxide. Without decay, carbon stayed trapped in the wood, and oxygen levels skyrocketed to an astonishing 35%, compared to just 21% today. This hyper-oxygenated atmosphere turned Earth into a playground for monster insects. Insects don't have lungs. They absorb oxygen through tubes in their bodies. With this much oxygen, they could scale up drastically. Dragonflies grew to the size of eagles, and millipedes grew longer than a human. Eventually, this massive pile of unrotted wood, combined with billions of tons of dead marine plankton in the shallow oceans, was buried by miles of sediment. Trapped in a high-pressure, high-heat geologic slow cooker, the oxygen was squeezed out, leaving behind dense strings of pure hydrocarbons. Marine life became the liquid petroleum we hunt for today, and the unrotted trees became our massive coal veins. It required an evolutionary delay on a global scale. So oil requires an abundance of complex life, an evolutionary lag where nothing can decompose it, and millions of years of perfect planetary baking. Which brings us back to our ultimate question. Is it the rarest commodity in the universe? To answer that, we have to look at the rare earth hypothesis. While some single-celled alien slime might be common on distant moons, complex, multicellular land life, like a tree, is likely an extraordinary statistical anomaly. Think about what a tree requires to exist. It needs a planet with stable plate tectonics to recycle carbon. It needs a massive moon to stabilize the planet's axial tilt and keep the climate steady. It needs a powerful magnetic shield to block solar radiation from frying complex DNA. And it needs hundreds of millions of years without a total planetary sterilization event, like a gamma ray burst, to give complex plants time to evolve. If complex land plants are rare, then the specific evolutionary glitch that created oil is a fraction of a chance. Physics can make a diamond planet anywhere. Only an unbroken chain of biological miracles can make oil. We treat petroleum like it's cheap. We burn millions of barrels of it a day just to commute, and we refine it into disposable plastic forks that we use once and throw away. But on a cosmic scale, that cheap plastic fork and that gallon of unleaded fuel are more structurally complex and infinitely scarcer than the largest gold asteroid drifting in the asteroid belt. The next time you pull up to a gas station, take a look at that liquid fuel. You aren't just pumping gasoline. You are witnessing the highly concentrated remains of an ancient biological miracle, one that 1,000 alien civilizations might look across the stars and envy. Smash that subscribe button if you learned something mind-blowing today. Leave your thoughts in the comments, and as always, keep looking up.